Yes, 300 amp panels do exist. It is possible to run the panel feeds for two 200 amp panels in a 3-inch polyvinyl chloride or PVC pipe. However, it is important to ensure that the pipe is properly sized according to the National Electrical Code, or NIC. To accommodate a backup generator, installing a transfer switch will allow for switching between utility power and generator power. The NEC requires a ground rod be installed at both the service equipment and the house. Installing a trough at the service equipment with main disconnects for the panels is a recommended practice. This allows for easy disconnection of the panels from the service entrance during emergencies. When running conductors for multiple circuits or feeders in a single conduit, directing factors, as outlined in NEC Table 310.15 B3, 8 might apply. These factors reduce the allowable ampacity of the conductors to prevent overheating. The ampacity of conductors must be derivated based on the number of current-carrying conductors in the raceway. For example, if there are 4 to 6 current-carrying conductors, the ampacity must be derivated to 80% of its original value. If there are 7 to 9 current-carrying conductors, the ampacity is derivated to 70%. Always consult the NEC for the specific derivating factors applicable to the installation. When using a transfer switch for a backup generator, it is essential to differentiate between two main types, manual and automatic. A manual transfer switch requires someone to physically switch the power source from the utility to the generator during an outage. An automatic transfer switch, or ATS, automatically detects a power loss and switches to generator power without manual intervention. Choice depends on the desired level of convenience and the criticality of maintaining power during an outage. Selecting the right transfer switch involves considering the load requirements, the generator's capacity, and local electrical codes. The NEC specifies requirements for transfer switches, including proper labeling, grounding, and overcurrent protection. The transfer switch should be listed and labeled for its intended use and installed according to the manufacturer's instructions. Grounding electrodes, such as ground rods, are a crucial part of the electrical system, providing a path for fault current to return to the source and activate overcurrent protective devices. The NEC specifies the size and type of grounding electrodes, as well as the methods for connecting them to the grounding system. Typically, a ground rod must be at least 8 feet long and made of copper or copper-clad steel. The grounding electrode conductor, which connects the ground rod to the grounding busbar in the service equipment, must be sized according to NEC Table 250.66, based on the size of the service entrance conductors. When installing a trough at the service equipment, it is essential to select one that is appropriately sized to accommodate the conductors and connections. The trough should be listed and labeled for its intended use and installed according to the manufacturer's instructions. The NEC provides guidelines for the installation of troughs, including requirements for bonding, grounding, and conductor fill. The conductors in the trough must be properly supported and secured to prevent strain on the connections. In addition to main disconnects at the trough, each panel should have its own main breaker to provide overcurrent protection for the branch circuits. The main breaker in each panel should be sized to protect the panel's busbar rating and the ampacity of the feeder conductors. Coordination between the main disconnects at the trough and the main breakers in the panels is essential to ensure selective coordination and prevent nuisance tripping. Selective coordination means that only the overcurrent device closest to the fault will trip, minimizing the impact on the rest of the electrical system. When running conductors through a conduit, it's crucial to consider the conduit fill requirements specified in the NEC. The conduit fill is the percentage of the conduit's cross-sectional area occupied by the conductors. The NEC limits the conduit fill to prevent overheating and ensure that the conductors can be easily pulled into the conduit. The allowable conduit fill depends on the type of conduit, the number of conductors, and the size of the conductors. NEC Chapter 9, Table 1 provides the maximum allowable conduit fill for various types of conduits and conductor combinations. The ampacity of conductors is affected by several factors, including the ambient temperature, the number of conductors in a raceway, and the type of insulation. The NEC provides ampacity tables that list the allowable ampacities of conductors based on these factors. It's important to select conductors with an ampacity that is sufficient for the load they will be carrying and to apply any necessary directing factors. The NEC also specifies requirements for conductor identification, including the use of color coding to distinguish between different types of conductors. For example, the grounded neutral conductor must be identified by a continuous white or gray covering, while the equipment grounding conductor must be identified by a continuous green or bare covering. Proper conductor identification is essential for safety and to prevent wiring errors. Bonding is the process of connecting metallic parts of the electrical system to create a low impedance path for fault current to return to the source. Bonding is essential for safety because it helps to ensure that overcurrent protective devices will trip quickly in the event of a ground fault. The NEC specifies requirements for bonding, including the size and type of bonding conductors and the methods for connecting them to the metallic parts of the electrical system. All metallic parts of the electrical system, including conduit, enclosures, and equipment, must be properly bonded. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges caused by lightning, utility switching, and other transient events. SPD are typically installed at the service entrance and at subpoles to provide comprehensive surge protection for the entire electrical system. The NEC specifies requirements for the installation of SPD, including proper grounding and overcurrent protection. The selection of an SPD depends on the voltage and current requirements of the electrical system, as well as the expected surge levels. Arc fault circuit interrupters, or of size, are designed to protect against fires caused by arcing faults in electrical circuits. SIs detect the unique characteristics of arcing faults and trip the circuit breaker to interrupt the flow of current. The NEC requires SIs to be installed in branch circuits that supply receptacles in bedrooms, living rooms, and other areas where arcing faults are likely to occur. SIs provide an additional layer of protection against electrical fires and are an important safety feature in modern electrical systems. Ground fault circuit interrupters, or GFCIs, are designed to protect against electric shock caused by ground fault. GFCIs detect small imbalances in the current flowing through a circuit and trip the circuit breaker to interrupt the flow of current. The NEC requires GFCIs to be installed in branch circuits that supply receptacles in bathrooms, kitchens, and other areas where there is a high risk of electric shock. GFCIs are an essential safety feature and have saved countless lives by preventing electrical shock injuries. When installing electrical equipment outdoors, it's important to select equipment that is rated for outdoor use and to protect it from the elements. The NEC specifies requirements for the installation of outdoor electrical equipment, including requirements for weatherproofing, corrosion resistance, and protection from physical damage. Outdoor electrical equipment should be installed in a location that is accessible for maintenance and repair. The use of proper wiring methods is crucial for ensuring the safety and reliability of the electrical system. The NEC specifies various wiring methods, including rigid metal conduit, electrical metallic tubing, or IMT, non-metallic conduit, and cable wiring. The choice of wiring method depends on the application, the environment, and the local electrical codes. All wiring must be installed in accordance with the NEC and the manufacturer's instructions. Proper labeling of electrical panels and circuits is essential for safety and to facilitate maintenance and troubleshooting. The NEC requires electrical panels to be labeled with the voltage, amperage, and phase of the incoming power supply. Each circuit breaker should be labeled with a description of the loads it serves. Labels should be clear, legible, and durable. A panel schedule, which lists the circuits and their corresponding loads, should be posted inside the panel door. Electrical inspections are an important part of the electrical installation process. Electrical inspections are conducted by qualified inspectors who ensure that the electrical work complies with the NEC and local electrical codes. Electrical inspections help to identify potential safety hazards and ensure that the electrical system is installed correctly. It's important to obtain all necessary permits and inspections before energizing the electrical system. Regular maintenance of the electrical system is essential for ensuring its safety and reliability. Regular maintenance should include inspecting the electrical panels, checking for loose connections, and testing the operation of GFCIs and FSIs. Any damaged or worn electrical component should be replaced promptly. It's important to keep the electrical panels clean and free of obstructions. The National Electrical Code, or NEC, is a comprehensive set of standards for the safe installation of electrical wiring and equipment. The NEC is updated every 3 years and is adopted by most states and local jurisdictions. It's essential for electricians and electrical contractors to be familiar with the NEC and to follow its requirements when performing electrical work. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is a valuable resource for ensuring the safety and reliability of electrical systems. Continuing education is essential for electricians and electrical contractors to stay up to date on the latest electrical codes and technologies. Continuing education courses cover a variety of topics, including changes to the NEC, new electrical products, and best practices for electrical installations. Continuing education helps electricians and electrical contractors to maintain their skills and knowledge and to provide safe and reliable electrical services. Safety is the top priority when working with electricity. Electricity can be dangerous and can cause serious injury or death if not handled properly. Always follow safe work practices when working with electricity, including wearing appropriate personal protective equipment, using insulated tools, and energizing circuits before working on them. If you are not qualified to work with electricity, hire a licensed electrician to perform the work. Always respect the power of electricity and take the necessary precautions to protect yourself and others from electrical hazards. Remember to consult the NEC for specific requirements and always prioritize safety.